So now I don't even have to give my talk. The code's on GitHub. I'll post some demo videos. Have a nice day. So quick intro slide. I'm John from Maine, application security consultant at Invisium. My hobby is writing code. Lately, I've been doing a lot of wood stacking and apple picking. Anyone else here from Maine by any chance? Yeah, I didn't think so. That's too bad. I was hoping to get some help stacking the rest of my wood, but I don't think you guys want to come for the travel. So as an application security consultant, that means I'm in the business of helping developers fix their code and their problems by breaking them and pointing out their flaws. I'm here today to talk to you about a tool I built that I'm releasing that kind of helps me at least do my job a little more efficiently, and hopefully you guys can get some use of it as well. So before I dig into the details of the talk, I just got to kind of rant a little bit, and there's just a few things I want to bring up. Who here is a developer? Okay, and do we have any other application security testers or any? Yeah, only a few of you. Okay. So one thing that bugs me is the use of the term penetration tester and then vulnerability assessments. There is a subtle difference, in my opinion, between these two terms, and everyone always disagrees. As far as I'm concerned, penetration testing is more focused on depth over breadth. So an organization is seeking a penetration test. They want you to get as far into their app or their network as you can by going deep. And with a vulnerability assessment, it's a little different because they want to identify the outlying vulnerability at a certain level, and the level is normally an external level. So as an example, you may have a website, and with a vulnerability assessment, you'd want to identify as many vulnerabilities as you can on the website. Now, if we were scoped for a black box penetration test, they may want us to try to break into the website to a point where we can use that to pivot throughout their network and steal more of their data. So if you're ever involved in the scoping process for consulting engagements, you kind of do have to know that there's a difference, and sometimes clients don't know what they want. So it's kind of our job to help them figure out what they want. So at Invisium, we do a lot more vulnerability assessments than we do penetration tests. So a large part of our job, obviously, is doing reports. So when all is said and done, the client expects a report from us that details what we found, how we did it, why it's important. If they don't get that, what are we really giving them? There's really no value. One thing I see a lot in reports is a similar phrase, or this exact phrase that says, an attacker could. So when you discover, a potential vulnerability and you're writing up the report, a lot of times we'll say an attacker could exploit this to do X, Y, and Z. Now, if you're being paid to perform the assessment or perform the penetration test, you are the attacker. You probably should be doing this, right? If you can do it, you need to do it. And that varies because a lot of times that stuff will be talked about in the scope, and certain things you can't dig in and you can't actually do it. It depends very much on the scope of the assessment. So the impact statements have to be practical. For an example, an attacker could intercept the NSA's unicorns and ride them to Mars. That's not super practical because we know the NSA doesn't have unicorns. And unicorns probably can't fly all the way to Mars. I'm not sure. They probably have to consume oxygen too, I think. So that's a non-practical example. This, on the other hand, is a very practical example. An attacker could enumerate a list of user accounts. Seems pretty easy to do. If you're the attacker, you should probably do that. So in a traditional assessment, the attacker is generally only one person. Now that varies, but generally it's one person sitting behind a computer, hopefully a MacBook Pro, generally connected to the internet, right? Most of the time we're doing work over the internet. Sometimes it's on site, directly with the client or over a VPN or something. But the general consensus is there's a computer that I'm controlling, there's the internet or some sort of connection, and then there's a target. This model is fairly unrealistic, and it's also slow. So what do I mean by unrealistic? Well, if you've ever looked at web server logs, you're not being hit by just one user. There's tons of IPs scanning you constantly. your server needs to know how well it can handle the load or how it's going to react in those circumstances. So we don't build apps for one user, we build it for many users. And so having one attacker controlling one computer who's targeting your application, that's not very realistic. So as a community, we can definitely improve on this model. And so this is what I'm here to talk about today. So there will be live demos. There will be live demo failures. I do have video backups, so we should get to see something cool. And just a side note, Verizon coverage down here is not great. What do you guys normally use for cellular service? AT&T? Ugh. In Maine, we have AT&T as of like 5 years ago, but it's only on the highway. So if you travel anywhere like outside of the highway, you just lose coverage completely and you get lost pretty much because your GPS can't tell you where to go. So the tool is called Httpillage. The HTTP part is pretty straightforward. That's the protocol we're attacking. Pillage, traditionally, as a verb definition here, means to rob using violence, especially in wartime. And when we're thinking of ourselves as attackers, we need to be attacking pretty violently. The bad guys of the world aren't going to be gentle and nice when they're attacking your servers. They're going to be violent, and they're going to do what they have to do to steal your data. That's not always the case, but I kind of like to assume the black hats are always very violent. So Httpillage is a tool designed for the distribution of attacks. Anyone here test web apps security, like on a day-to-day basis? 1, 2 people? Wow. It's kind of expecting more of you. So this tool, like I said, is designed to basically allow you to distribute certain attacks. And we'll go through some examples. It's still very beta. I just pushed the code up a few nights ago. It's on GitHub. The link will be at the end of the presentation. There's obviously going to be bugs. There's obviously going to be improvements. But I want feedback from everyone to see how we can improve it. And it was originally a hackathon project. So most of the code was written in about 24 sleep-deprived hours. So anyone a Ruby or Rails developer? Wow. I'm not sure I'm comfortable talking to you folk. No security testers, no Rails developers. Whew. Well, the reason I asked is, as you see here, Httpillage was written in Ruby and Rails. So it contains a web interface, and that web interface allows you to create what I call a job. So when you're attacking a server, you would do that via a job. And like I said, I'll demonstrate this. Has user management because obviously we want users. If we run a company, so if we have a consulting company like we do at Invisium, we have more than one employee, and we want to be able to control who has access to it. Is that better? Yeah. So user management, that's pretty obvious. Any tool with a web interface generally has some sort of user management. It also has response tracking, so you can kind of just sit and look at the beautiful web interface and see what's going on with your requests. Burp Suite integration, I have to ask, who here uses Burp Suite on a day-to-day basis? Yeah, the general suspects. No. There's a green light, yeah. So, part of the tool, I also built a Burp extension that will allow you to send the requests very easily from Burp to the Httpillage server. And as of right now, it supports 3 major attack types: repeating, dictionary, and brute force. I'm going to go through a live demo of each of those. But in a general sense, what I consider a repeating attack is essentially denial of service. So you have a web request, and you want to send that over and over again as fast as you can to see how the host reacts. And generally, it's not going to be very well. Dictionary, pretty obvious. You upload a dictionary file. You can use that to iterate through for username enumeration, known passwords, things like that. And then brute force, it's great for testing password strength. It also supports response flagging, which is important if you actually want to get results out of the tool. So if you use Burp Suite, you're pretty familiar with the intruder function, I'm sure. And what makes that useful is that you can actually see the response and you can search it by strings or regular expressions to kind of monitor the application's behavior. So in a general sense, there are two major parts to Httpillage, a server and then nodes. Pretty straightforward. The server is a command and control server, so if you've ever worked with any botnets or botnet controllers, it's not too different in the sense that the server is the general point of interaction for the attacker, and that delegates work out to the nodes. And then nodes are the ones that are actually sending the request to the clients, and they process the request for matches. So, I showed you the traditional testing diagram, and this is kind of what it would look like now with distributing our attacks. So we have a user that's controlling a command and control server. That's the only thing I'm touching as the attacker. The command and control server is then telling the nodes what to do. They're basically sending the requests to the nodes, and the nodes are sending those to the targets. And they're analyzing them, and the nodes do most of the dirty work. And so in this case, now we have the nodes, like I said, directly attacking the target. So I have a little animation here just to kind of demonstrate the flow. So node, it polls for a job. So it sends a request to the server saying, hey, is there any work for me to do? Give me something to do. And that occurs about every 3 seconds. And if it does not receive a job, it just continues polling. Pretty straightforward. If it does receive a job, we begin to parse the payloads, see what work we need to do, make sure it's well-formed. If we don't have any payloads, we're just going to continue polling again, because that means we probably already finished the work. If we do have payloads, that's when we actually send the request to the target. So we form the request on the node, we send it to the target. We then look to see if there are any matches. So like I said, there's response matching, which is really useful. And the nodes actually do the response matching on the request directly. If there's no match, we then just check if the work's complete. If there is a match, we send it back to the command and control server. So like I said, the command and control server kind of controls all the data. That's our central point. If the work's not complete, we just iterate, keep sending requests. Obviously, if it's complete, we're going to go back and continue polling. So, the idea is that the nodes will just be stored on some computer or some instance online. I've been using Amazon, but they probably wouldn't be happy to hear me say that. So you might want to look at using some other services or just hosting some machines yourself. All right. Let's see if we can fail at some live demos. You guys are all probably fairly confused right now. I blew through that pretty quickly, but I'm going to explain in more detail while I'm going through the live demos. This is the best low-resolution image I could find that kind of related to the talk. So obviously, I'm going to have a cat photo in my slides. The fact that it's super low resolution just makes it even better. All right, username enumeration. Who here knows what this means? Okay, that's probably a good thing. So this is a very common finding, and it occurs when the application discloses existence of a username or an email address. And we see this, like I said, very commonly, normally in login mechanisms, forgot password mechanisms, and also almost all user registration mechanisms are vulnerable to this. So as an attacker, we can discover username enumeration by looking for verbose error messages. So I'm sure everyone here has seen an error message at one point that says, the username does not exist in the system, or incorrect password for username. And that tells us, okay, that username does exist in the server. Response diffing. Sometimes the page will respond slightly differently if the user account exists or not. It may be a response code. So you may get an HTTP 302 redirect if the account exists. You may get a 404, something along those lines. And also timing. A lot of websites are vulnerable to username enumeration via timing bugs. And it's very theoretical, but sometimes it can be practical. So I wrote a blog post on that a few months back if you're interested. it's normally not something we test for because, like I said, it's generally not practical, but it can be. So yeah, Facebook's vulnerable to username enumeration. If you try to log in with an account that doesn't exist, it basically says incorrect email address. It's pretty straightforward. Twitter is also vulnerable to username enumeration. I don't feel bad saying this because they've expressed the fact that they don't care and they're not going to fix it. So a lot of organizations really don't care. So username enumeration is an interesting vulnerability because it's on its own, it's really not that useful in most cases, and that's why a lot of organizations don't care. But if we're doing a black box engagement and we're trying to do some recon on the users or the employees, username enumeration tells us a lot because we can use it to start launching phishing attacks. We can use it to try to do some password discovery. Sometimes if you know the user account that exists in the system, you can use that in insecure direct object reference vulnerability. And also for de-anonymization. So, if Ashley Madison's vulnerable to username enumeration, obviously, my wife is going to see if I'm on there by, leveraging this username enumeration flaw. And, if you try to stay anonymous online, username enumeration can kind of kill you if you're not smart about it. So don't use your .gov email addresses. Process for exploitation is generally pretty straightforward. As an attacker, we want to build a list of email addresses or usernames that we know are valid and generally exist. So Adobe Database Dump is a great place to look because there's well over 4 million unique email addresses contained there. So if I'm testing your website or your service for username enumeration, I can just pound through all those Adobe Database email addresses and see if they have accounts on your server. So given the dictionary list, we establish a baseline request, which means we try it manually first. And then we can use the dictionary to automate that process. And we search for the patterns that indicate that it's vulnerable, such as the verbose error message, the HTTP response code, etc. So yeah, I kind of talked about this a little bit. I mean, it's generally very low impact, but it's also low difficulty, which if you're into, risk analysis and things like that, that would generally mean it's a moderate risk. But like I said, most organizations consider it low. A lot of people don't even bother to fix it. So it all depends who you are and what your users are doing. So I'm going to switch over, do a live demo. Or at least try to do a live demo, and then if not, we're going to be watching some videos. Videos are cool. Oops. All right, so if you're not familiar with Burp Suite, this is Burp Suite. Wow, that is terrible. Well, you won't need to see a whole lot of the details there. Yeah, I don't even think it's worth it, to be honest. So Burp Suite's an intercepting proxy. I use that every day in my life. Pretty much all my traffic flows through Burp Suite. This is not a Burp Suite product pitch, by the way. I like it as a tool. So Burp Suite has extension capabilities, and I wrote an Httpillage extender. And so if you install it, you'll see an Httpillage tab up at the top. So there are a few values we have to enter here in order to make things work, and we'll get to that in just a second. So as far as the user interface goes, this is it. It's Rails. I'm going to log in. If one of you was nasty, you could probably find my password because it's in the source code. But then you would ruin my live demo, and I would not be happy. But it would be funny, so it's probably worth it. And we'll see if my network connection's working. This is actually hosted on a server somewhere, so I do need network connection. And if that doesn't work, we'll go to the videos. Hey, it worked. So when you're first starting off, the most important tab would be settings. Yeah. I think we're going to switch to the video. What do you guys think? This is painful. Don't blame me, blame Verizon. All right, so I'll try to narrate what's going on. Let me make this, can I make it full screen? Can you guys see that well enough? So obviously I'm logging in, pretty straightforward. Generally you want to have some sort of authentication on your apps. If you're not doing that, you probably should be. Never save your passwords in your browser. That's just an extra security tip. So, like I said, eventually I'm gonna click on settings. We just kind of. All right. So what I'm demonstrating here is the dictionaries part of the tool. So as I said, one of the features it supports is a dictionary attack. And in order to make a dictionary attack successful, you have to have a dictionary. So this allows you to upload a dictionary to the server that you can use for the attack. So this one that's already here is a 500 worst passwords dictionary. That comes preloaded with Httpillage. So once you upload the dictionary, you can actually download it again just so you can verify what it is. Not super useful, but it gives you access to it. So I'm going to upload a new dictionary. I have a habit of moving my mouse around a lot when I'm recording demos, I notice. If you watch, you'll see me just move the mouse around, which is kind of weird. Things people do. So yeah, just a normal file upload system. Select the dictionary, give it a description, upload, cloud stuff. It's stored somewhere and it's accessible. Gives you a quick preview, just so you kind of know at a high level what the dictionary is before you start using it. All right, so WordPress. Who here uses WordPress? Wow, people are actually willing to admit to it. Yeah, WordPress is. I've used WordPress. I know a lot of people that use WordPress. So I like to pick on it. WordPress obviously vulnerable to username enumeration. I don't know why they won't fix it, but it's definitely been reported. So the login page. It's pretty easy to detect if a website's using WordPress. It's very straightforward. So there are a lot of attacks specific for WordPress. So if you are using WordPress and you're not updating it daily, you're going to have a bad time. So I'm just starting with a bad username, bad email that doesn't exist in the server. And what you see is a verbose message that says invalid username. If we provide a username that does exist and an invalid password, it responds with a completely different message. So, that tells us, okay, that account does exist. We just don't have the password. So what I'm doing here is I'm actually going to take that request from Burp's proxy history, and then I want to send that to the server because that's the request I want to automate. But before I do that, I actually have to set the credentials for the server in the URL. So just changing the URL to point to my CNC server, which is hosted on the cloud. And then there's a token you have to provide, and the token is unique to your install. It's just a form of basic auth. It's not great. We can improve on that, but it's just something quick to kind of prevent the bad guys from, hacking my video recorded demos. So you can find this stuff out in the settings panel. Just paste it in there, and then theoretically you should be able to create jobs. Obviously, we want authentication because we don't want someone to just maliciously add jobs to our command and control server. That would not be good. So theoretically, that token is unique and only we would know it, and that's why it kind of works. But so I basically just right-clicked on the job, send to Httpillage. It parses it up, and then you get to see the job in the user interface. So the HTTP headers are displayed there. We also have a few different tables, which will become important later when we actually run the job. When we send the job to the command and control server, it doesn't start automatically. We have to go in and manually start it. So what we're going to do is we're going to actually edit it to do that at some point, once I finish moving my mouse around. really hard to like record like demos like this and then talk about them because like it always changes. You never know exactly what you're going to say, so you're constantly stopping and starting and moving your mouse and doing weird things. So now that I'm actually editing the job, I'm just going to provide a quick description. So we can edit the HTTP headers we want to send. We can edit the HTTP post data. What I'm adding here is I'm adding a response flag. So I'm adding the phrase I want the nodes to search for, and this will tell me whether or not this particular payload did exist in the server. You can use either a string or a regular expression. And in this case, when WordPress does have an account that exists and you provide the wrong password, it uses the unique phrase incorrect. So theoretically, if the phrase incorrect occurs in the HTTP response body, we know the username exists. So just a little tidbit there. So changing the attack from repeat to dictionary, and then I'm selecting the dictionary we want to use, which is the Adobe email address dictionary that we just uploaded. Then starting. So what I just did there is I actually found the parameter that's vulnerable, which in this case was log, and I replaced that with the payload marker. So if you use burp, you're used to the payload markers burp uses. In Httpillage, we just use, what are those called? Squiggly brackets? That's what I'm going to call them. Squiggly brackets, P, and then that tells you, or that tells the nodes where to insert the payload.
Curly braces?
Curly braces, there you go. Squiggly bracket sounds better. More technical. So at this point, the job's actually started. So any node that's sitting on the internet polling for a job would receive this and it would start doing its thing. So what you saw right there is that table actually started populating with the HTTP status codes and also the node IDs. So when I'm just sitting looking at the user interface, it's polling, doing some Ajax-y stuff. And that tells me right now I have at least 4 nodes that are targeting that server, and they've all received valid status codes. So that tells me nothing's broken. The web server is responding correctly, which in a lot of times it doesn't. So I'm going to actually spin up another node here locally. And so the node is actually I should have increased the font size. So a node is a Ruby script. So it's pretty easy to get started. In here, we're specifying the server address, certificate path, because I'm actually using SSL, and then the API key. So the API key just kind of authenticates the node so we know we're not having rogue nodes join our CNC server, and also the thread count, how many threads we want it to use. And so pretty much instantly it receives the job and it receives a bunch of data. So in this case, there's about 100 email addresses, and that's considered the job's work. So those are the email addresses that node is going to be responsible for enumerating through. So the CNC server is what actually delegates that work out. Then it just sits, sending those requests, verifying the responses, and it does that for a little while. So I'm just going to fast forward. It took probably a few minutes, but if you look at the match string, you can't really see it very well. But under job matches, what you'll see is eventually we'll have a result. All right. So as soon as we found that result, it populated there, and what that indicates is that that particular email address did exist in the server. So now we can be malicious and we can take that and we can try to log in. So the nodes are going to keep going, looking for more email addresses, but that was a positive result. So yeah, any questions about that?
Yeah, use this tool like in your dev environment. Would you be running the CNC server and up to 10 nodes like the local services to test your or that, or are you hosting this stuff in the cloud?
I host it right now in the cloud, but if you have the resources to do it locally, you could do that as well. So if you're a developer and you want to try doing this, you could very well do it locally.
So the HTTP pillage is basically a collection of those services, the CNC and the nodes.
Yep.
All running separately.
Right.
Okay.
So you could have the CNC server running locally and the nodes running on the cloud pointing back to it. Yep. So that email address, we just found out it existed in the server, and obviously that guy's using a weak password, so I think we'll get in. We'll have to see. But you see, that's a good example of the verbose error message. So that's completely different. In that case, it says the password for that particular user is incorrect. So we do know he exists. And then we're going to get in. So yeah, that's username enumeration. Hopefully everyone is already familiar with it, but that's how we can actually increase the exploitability of it. Because when we're testing locally, it takes a long time to actually enumerate through that many requests, and it makes it kind of unfeasible. But if we can distribute it out, it really increases the performance. Mm-hmm. Yep. If you don't mind, I'll get back to that at the end. I have 2 more demos I'd like to try to get through if I can. This expiring tokens, this is an interesting situation because I was performing an assessment and I discovered a vulnerability relating to tokens that were supposed to expire. And that's what made me see the need to write a tool to do this stuff. So when I say expiring tokens, I'm talking about hopefully random tokens that are used for out-of-band communication that expire in some certain time window. It might be 60 seconds, it might be 15 minutes, it might be a few hours. And the idea is that theoretically we could probably brute force those tokens if they're weak, but given that we have such a small time window, it's hard, and the only way we can solve that problem is by allocating more resources. So they're very common, especially with multi-factor auth, and forgot password mechanism. So as an example, Google Authenticator uses a 6-digit token. It's a very small time window. I think theirs is only 30 seconds or 60 seconds. So feasibility for actually brute forcing that in the time window they have is pretty small. But if you've implemented it with a longer time window, it's fairly easy to actually exploit that. And I've seen that quite a few times. So I'm going to do another demo here. This demo is using a Django.nv, which is a tool we built that's actually an intentionally vulnerable Django application. Anyone here a Django developer? So if you check it out and want to learn more about Django security, it includes tutorials and everything to get you started. It's a great tool. I've used it twice. I'm not a Python person, but I think that was obvious when I said I'm a Ruby person. All right. So got Django NV running. I'm going to fast forward because so there's a forgot password mechanism in Django NV. And the way it works is you provide your email address, and then it sends you a unique token. Well, it should be a unique token. And so the idea is that you would receive the unique token in your email address, and you'd use that to confirm your identity before resetting your password. So, in this case, there's a few obvious flaws with this flow. Number one, when you specify your reset token, you're also specifying the password you want to change in the same request. And that makes it really easy to automate and brute force that. So what I'm doing is I'm just sending a baseline request with a token 0000 and a password I want to reset it to. And then I'm going to send that to Httpillage, and I'm going to edit that job. So if we're trying to test a 4-digit PIN, we're obviously going to be brute forcing it. Character set's pretty simple because it's just digits. So we're allowed to specify the character set. In this case, I specified 4 Ds, which means digit, 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 digit. We're going to start it. And what that's going to do is it's going to enumerate through all of the potential 4-digit tokens. Going to start it. So it's going to run for a bit, and then because there's no unique phrase or anything to search for, we didn't specify a pattern to look for. But theoretically, when this is done running, we will have reset the victim's password. So we wait till it's done, try it, and then we're able to get in. Sorry, I'm kind of bouncing around because she gave me the 5-minute warning like 5 minutes ago. So, but yeah, that's it. That's actually it's a fairly common vulnerability for companies to use weak tokens, and they kind of assume that because they expire in a certain amount of time, you're not going to have a problem. But theoretically, if you throw enough resources at anything, you can reduce the time it takes to complete it. So that's one case where this tool really comes in handy. No. That's not what I wanted to do. So the last thing I wanted to demo, I'll just talk about it real quickly, denial of service. So a few of you use WordPress. WordPress has an XML RPC file. If that's publicly accessible, you're going to have a bad time. Lately, there have been a lot of denial of service attacks against that file because it does XML entity expansion. So what we can do is we can actually exploit that and pretty much bring a server to its knees right here. So we'll skip the fluff and we'll just get into the video. This is an intentionally vulnerable version of WordPress, so theoretically, if you're up to date, you won't have this issue. But so I just made sure the XML RPC file is accessible. And then we have a custom job we're going to run. Okay. So it's basically an entity expansion attack, which consumes all of the server's memory. So if you can see in my terminal window there, I'll have top open so you can see the memory usage and the CPU load. And then pretty much as soon as I start running it, we'll see that spike. And this is a pretty serious flaw in WordPress because it would cause, if you're running MySQL, it would cause MySQL to crash, and it would have to be manually spawned again. So you can see the usage is spiking pretty quickly. And then eventually you're going to see that. And that works pretty much without fail on WordPress 3.9 and below. So if you're running one of those with XML RPC open to the world, it's very easy to take you offline. In this case, I only used 1 node, and that was locally. So if I had scaled this and we're hitting you with 10 nodes constantly, no matter how big your server is running it or your load balancers, we can take it all down pretty cheaply. But that's just denial of service. No big deal. All right. Great. Well, I think I'll pretty much have to wrap up since I'm out of time, but there's a few resources here I'll just leave up. Yeah, I didn't do any research. I literally got the idea, started building this tool because I needed something. So there could be something out there that already does this, but I don't know. We have a cool web interface. And good job. We made it through the last set of talks for the day. So we can find out now who won prizes and then hopefully get some sleep at some point tonight.
Thank you very much, John.
Thank you.